De Morgan's laws for sets are these two set equalities. You have A union B complement is equal to A complement intersect B complement, and A intersect B complement is equal to A complement union B complement. These are De Morgan's laws for sets. Now, in this video, I want to show you why they're true, and I think why I'm actually going to show you why this one's true. The other one is true for exactly the same reasons. Now, you might be saying, well, why do they call these De Morgan's laws for sets? Well, these really just follow from De Morgan's laws. These are really just a rephrasing of De Morgan's laws into the world of set theory. Okay, so let me show you why this is true. And remember, De Morgan's laws are really important, so it makes sense that I would show you this as well. Okay, so A union B complement. Right, just break this down. This is the set of all x in U such that x is not in A union B. Now, what does it mean for x to not be in A union B? So if we're in our universe, and here's A and B, if you're not in A union B, then you can't be in A, and you can't be in B. Because if you were in A, then you would be in A union B. And if you were in B, then you'd also be in A union B. So what it means for x to not be in A union B, that means that you've got to be out here. You've got to be outside of A union B. So logically, that means if you're not in A union B, then x is not in A and x is not in B. Well, that just means that x is in A complement and x is in B complement. And this is really just the definition of what it means to be in the intersection. This is A complement intersect B complement. Now you might be saying, hey, okay, sure, this is true, but where did you use De Morgan's laws? And let me show you. Okay, De Morgan's laws is used in this step right here. All right, so let's see what I mean by that. So in terms of, these are statements really in logic. And what the statement is that x is not in A union B is equivalent to x is not in A and x is not in B. So let's see why that is using De Morgan's laws. All right, remember De Morgan's laws for or. The negation of P or Q is equivalent to not P and not Q. Now remember, the upside down V, that's or, so I'm just going to write in or there, so make this a little more intuitive. Make this into an and. And now we're going to say that P is the statement X is in A, and Q is the statement X is in B. So if P is the statement X is in A, then this thing on the left here, this right here, is really saying not X in A or X in B. And the thing on the right, this is saying it's not the case that X is in A, so that's the same as saying, okay, this is not X in A and not X in B. All right, and so that's really how this is going to work for us. Okay, so now we just derived, right, that that in fact that this is true. And that's really only taking De Morgan's law here and saying what exactly P and Q are. P is X is in A, Q is X is in B. So now, right, remember what we were trying to show here, right, was this thing, that these were equivalent statements. Because this is the part, this is where De Morgan's law is used. In this thing I have above here, right here, where I had in blue. All right, so starting on the left-hand side here, X is not in A union B. We can think that's the same as saying not, that's the negation of X is in A union B. Now remember, what does it mean for X to be in A union B? That means that X is in A or X is in B. Now by this equality here, put that in a blue box or something. By the blue box, right, that is equivalent to not X in A and not X in B. Remember the thing in the blue box is really just a special case of De Morgan's law. One of De Morgan's laws. Okay, not the negation of X is in A, that's X is not in A, and the negation of X is in B is X is not in B. So you see here that I've shown that this is equal to that is equal to that. That's really just a consequence of De Morgan's laws. And this is exactly where we use De Morgan's laws to show that the complement of A union B is equal to the complement of A intersected with the complement of B. That's what I have in blue there.